Okay, guys. So on question 5, it is once again just application of your vocabulary. Okay. So on this first question for angle 5, we're talking about angle bisectors. All right. So all of the angle bisectors of this triangle XYZ. Okay. And what you're going to notice here, all right, is that they're all meeting at this point P right here. And we know that the point of concurrency for angle bisectors is an incenter. And what we know about incenters is that they are equidistant to the sides of a triangle. Okay? And then going from that, when we're talking about the distance from a point to a side or a point to a segment, it's the perpendicular segment connecting the two. So if you look at the 3 segments that I am highlighting here, all right, these are all congruent because this is showing the distance from the point, the incenter, to the side. Okay, which means that these are all 9. Okay, now the question is asking us to find PY. All right, so what we're looking for is this side length here. And so what I want us to focus on is actually this triangle. Okay, and the reason why we're focusing on this triangle is it first contains PY, but it's also a right triangle, and we have 2 side lengths. We have the 9 and the 17. And what we're trying to find is the hypotenuse of that right triangle because it's the one across from the right angle, okay? And so what we're going to use is Pythag, which is a squared plus b squared is equal to c squared, okay? Now, I'm looking for my py, all right? I'm going to call that x, all right? So I know that's my hypotenuse, which has to be my c, so that's x squared, okay? And then how you plug into the a squared and b squared doesn't matter, so I'm just going to do 9 squared plus 17 squared. Okay, and then you guys can solve on your own, but what you're going to finally get is x is equal to the square root of 370, which is approximately 19.2. So for our next one, we're dealing with perpendicular bisectors. Okay, so if you look at all these perpendicular bisectors, what you're going to notice is that they are meeting at this point G. All right, point G is called the circumcenter. And what we know about the circumcenter is that it's equidistant to the vertices of a triangle. Okay, so if you look at the segments, all right, that are connecting that point G with the vertices, so A to G, G to C, and G to B, all right, all of these are going to be congruent. Okay, which means that if we're trying to find AG and we know that BG is 12, then AG also has to be 12. Okay, and you could have done the same thing for GC. This would also be 12. Now, our third one in this section is, once again, we are dealing with circumcenters, all right, which means that we're dealing with perpendicular bisectors. Okay, and perpendicular bisectors, all right, when they meet at the circumcenter, are equidistant to the endpoints, all right, just like the last question. So A is our circumcenter, all right, which means that A to R, A to Q, and A to P are all congruent, okay? And so this question is asking us to find X, Y, and Z, and X and Y are going to be done the same way because we know that AQ is 24. So then we're going to set up, all right, both of those segments equal to 24. So I'm going to have 8x plus 16 is equal to 24, and then you can solve. All right, and then 5y minus 6 is equal to 24, and then you can solve. Now, for our z, it's a little bit different, all right? And what we know about the bisector part of perpendicular bisectors is it has to pass through the midpoint, all right, which means that these 2 segments right here are congruent, okay? So to find z, you're going to do 7z plus 4 is equal to 18, and then you can solve, okay? Now, our last one, once again, we're dealing with incenters, which deals with, all right, angle bisectors, okay? And what we know about the incenter, once again, is that from the incenter, all right, to the sides are all congruent. So these 3 segments right here are congruent, okay? Now, what we're trying to find is this angle VZX, all right? So this is what we're trying to find right here, okay? And we're actually going to be using, all right, some information from last chapter. So what I want you guys to notice right here, all right, is that we know that XW is congruent to, all right, this YZ, all right, from our given information, okay? And that's going to be helpful because what we know is that that triangle right here is isosceles, which means that this angle is congruent to this angle, okay? And because, all right, it's an angle bisector, we know that this angle has to be 20, all right, which means that these two angles also have to be 20. So our missing angle here, all right, of VZX, all right, is going to be 20 degrees. Okay. All right, so to continue on with this little section here, all right, we know that DB is an altitude of triangle ADC. Altitudes, all right, are the segments that connect a vertex with the opposite sides, all right, at a right angle. They're perpendicular, okay? So we're given that angle DBC is n squared plus 81, okay? And because that's a right angle, we know that it equals 90 degrees. So we're going to set that equal to 90, all right? And then we're just going to solve. So we have n squared is equal to 9, all right? And here's the thing that you're going to see in my answer key, all right, is that you're going to see that n is equal to plus or minus 3. And this is slightly more Algebra 2 stuff, all right? But just recognize that no matter if you plugged in a positive 3 or a negative 3, all right, to that original expression of n squared plus 81, it's still going to result in a true statement. So if you just had 3, that's fine, all right? Plus or minus 3 is just a more mathematical one, okay? All right, so next one says that J is the incenter. Once again, we are dealing with angle bisectors, okay? And then from there, we also know that they are equidistant to the sides. So what we're given is that DE is 12, all right? And then we are given that JD is 13, all right? And what we need to find is JG. This is what we're trying to find right here, okay? And you're probably thinking, well, that's not even touching these sides right here, okay? But what we know is if the incenter is equidistant to the sides, we know that all 3 of these sides right here are congruent, which means that if we focus on this triangle right here, this right triangle, we can use our handy-dandy Pythag, all right, to substitute in. So I'm going to let this be x, okay? 13 has to be my hypotenuse. That has to be my c. All right, doesn't matter how you plug in the x and 12, but we have x squared plus 12 squared is equal to 13 squared. And what you're going to find is x is equal to 5, all right, which means that JE is 5, which means that JG and JI are also 5, okay? All right, our last one in the bunch here, all right, once again, deals with incenters, which means that we are dealing with angle bisectors. Okay, so angle JHI is 24 degrees, all right? Here's why this is helpful. This is also 24 degrees, okay, because it's an angle bisector, which means that all of angle H is 48 degrees. And I'm going to circle that because we're going to pay attention to the 48, okay? All right, GFJ, all right, is 19, okay, which means that because it's an angle bisector, that this is also 19 degrees, which means all of angle F is 38. I'm going to circle that. So what we need to find is angle IDJ. All right, this is what we're looking for right here, okay? And so what we're going to do is we're going to recognize that angle H, angle F, and angle D have to add up to 180, right? We have H and F, so we're going to take 48 and 38, and we're going to subtract them from 180, okay? Not drawn to scale, angle D is 94 degrees, okay? Now, because it's an angle bisector, we know that these two angles right here that have to add up to 94, not drawn to scale, all right, are both the same measure, which means that we can cut that in half, which means that we have 47